Good morning. Good morning, students. Good morning. Okay. So, as usual, first, before starting with today's concept, we have to talk about basic concepts of chemistry. Anyway, this is the chapter. Okay. So now, can anyone tell me what we had discussed in the last class? You can just type the words. Yes, good morning. Good morning to everyone. So what we have discussed? Okay, very good. Shubhangi, yes. So we have discussed about atomic mass unit. Atomic mass unit, right? So which can also be called as Dalton unit or simply as Dalton. So I can mention it as dA. Here I can mention it as AMU, or it can also be called as unified mass. Right? Symbol is U. So that's where we have the atomic mass unit. Okay, yes, before that we have discussed about significant figures. Yes, I'll come to that. So that's where we have discussed. So what do you mean by atomic mass unit? It is nothing but the mass which equals to, it is the mass which equals to one mass of 1/12 of the carbon 12 isotope. So what is atomic mass unit? It is the mass which equals to mass of 1/12 of the carbon 12 isotope. So that's what we have discussed in the last class, right? Now along with that, yes, I had forgotten. Before that we had discussed about very important one, that is significant figures, right? Now we know that zeros which comes before non-zero digits, they are not considered as a significant figures. Same time, zeros which comes after the non-zero digits without any decimal point are not considered as significant figures, right? But all the non-zero digits, definitely they are significant figures, and all the zeros which comes between the non-zero digits are significant figures, and all those zeros which comes after the non-zero digits with a decimal point, now it will be a significant figures, right? So that's where we have 100, where number of significant is 1, number of significant figures are 1. So if I take 2000, number of significant is once again 1 only. But if I write 2000, now we have the number of significant figures as 1, 2, 3, 4, 5. So number of significant figures are 5. So that's where we have the significant figures. One mark question they can ask. Anju, it's not 4, it should be 5. Counting mistake. So 1, 2, 3, 4, 5. Even this 0 we have to consider, because it is after the decimal point. No problem. So no need to worry. You can try to give the answer. Fine. That's where we have the concept which we have discussed in the last class. Okay. Now, when it comes to exam point of view, both are important. When it comes to exam point of view, both are important. Then we have discussed about scientific notation and solving some of the problems, right? So that's what we have discussed in the last class, that is with respect to scientific notation, fine, or scientific representation of some of the numbers, fine. So that's what we have discussed in the last class. Now when it comes to atomic mass unit, when it comes to atomic mass unit, now please remember that definition, it is important. I will make it very clear. Definitions are very important, but no one will ask you what is that one atomic mass unit, what is that value. It will not be asked. If you remember, no problem. Okay. So yes, Stefan, we have discussed about precise and accurate. See, once again I had forgotten. So precise and accurate, yes, we have discussed. So when it comes to the precise, it will be the nearby values, right? But when it comes to accurate, these are the values which we are going to expect, right? That's where we have the accurate and precise, fine. So whenever we are conducting any experiment, normally it will be precise. Getting accurate result will be a very difficult task. That is because it depends on the chemicals which we are using, and there can be human errors. So due to that, we will try to get the accurate result. I am using the word we are trying to get the accurate result. I am not telling that we are getting accurate results. Fine. So that's what we have discussed. Yes, when it comes to atomic mass unit, I will come back to today's concept. We have discussed about the atomic mass unit. So now when I am talking about this one, definition you can expect. Everyone will expect that as a chemistry students, you people should know how to define atomic mass unit. That's what everyone will be expecting. But it depends on the candidate. No one will expect that you should remember the values. What is that? Mass of 1/12 of the carbon 12 isotope. That's what yesterday we have discussed, right? So in that case, one piece. What is this mass which equals to? No one will expect you to remember. Okay? Fine. So now, for your information, for your knowledge, I will be mentioning it will be approximately 1.66 into 10 to the power of minus 24 gram. Can you see the value? 1.66 into 10 to the power of minus 24 gram. It's a very, very small value. It's a very, very small value. Fine? All of you have understood? Say for example, it is a scientific notation. Whatever I have written, it is nothing but a scientific notation. Right? Now, if I want to write in a regular number, then 166. 166. That means I have taken here this one as 1.66, try to understand this, into 10 to the power of 2. That will be giving 166. All of you will agree? So 10 to the power multiplied by 100. Now it will become 166. So that's where I have taken 166. That means I should reduce 2 from here. Because plus 2 minus 24. The answer will be minus 22. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So such a large number. So such a large number. It's minus 24 now. So I should take decimal point on the other side. I should take the decimal point on the other side. So I will keep it as 166. on the other side. So I should add this one. I will make it as minus 25. Okay. So such a small number. Can you imagine? Why I have taken decimal point here? 166 on the other side because it is minus 24. If it is plus 24, earlier whatever I had written was correct, but it is minus 24. So decimal point should be here. After that 166 will come. All of you have understood? Such a small value. Can you imagine? Every time whether we can represent like this? No. So therefore that's where we have the advantage of scientific notation. There is no chance of errors. Now I can make the errors over here. I can miss 1 or 2 zeros. So to avoid all those things, we have the scientific notation. Fine? All of you have understood? So such a small value it is. So that is nothing but 1 atomic mass unit value. Okay? Now we will see what will be the atomic mass unit of hydrogen. What will be the atomic mass unit of hydrogen? Okay? Now, if I take one hydrogen atom, so this is with related to mass, that is 1/12 of carbon 12 isotope. Whatever I have written on the board, it is the mass of 1/12 of carbon 12 isotope. That means this portion, this is the mass. If I take one hydrogen atom, it will weigh somewhere around 1.67 into 10 to the power of minus 24 gram. That is the mass of one hydrogen atom. That is not the atomic mass unit. That is the mass of one hydrogen atom. Fine? Now, if I want to convert this one into atomic mass unit, so what I should do? I should use this information. What is that? One atomic mass unit is nothing but this value. Right? So in that case, what will be for these many values? What will be the atomic mass unit? I will write it here. Observe it carefully. For 1.66 into 10 to the power of minus 24 gram, we have one atomic mass unit. Or I can tell that these many grams corresponds to one atomic mass unit. In that case, these many grams corresponds to how many atomic mass unit? Got my point? So where grams will get cancelled. 10 to the power of minus 24 will get cancelled. So 1.67 divided by 1.66. Approximately it will be equal to 1 only. Approximately it will be 1.008 something it will come. So I have written it as approximately 1. Got my point? Now I can mention here it as AMU, or I can mention this one as U, unified mass, or I can mention it as Dalton mass. Got my point? This is with respect to one hydrogen atom. So this is the mass of one hydrogen atom in terms of atomic mass unit, in terms of Dalton, or in terms of unified mass. All of you have understood? Any doubts? Say for example, actually the value will be 1.00776 it will come. Now I will make it as round off. 1.008. This is called as round off. That means or to go for larger value, approximate value. See, after 7 we have 6, which is more than 5. So therefore we can take this one as 8. We can take that one as 8. Now even I have not considered this one because it is after 1, 2. At third decimal point we have the 8. So even I am neglecting that one. I am writing it as 1. Got my point? So these are with respect to our convenience, we can do all these arrangements. Okay? But we cannot do when we have 1.9. Observe it carefully. When we have 1.9, we cannot take it as 1. No, it's a blunder. Either way, we can take it as 2. That is fine. But this is wrong. Got my point? So when I have 1.9, I cannot straight away take it as 1. I can take it as 2 to make it easy for calculation purpose. Fine? All of you have understood? So that's where we have the 1 atomic mass unit or 1 Dalton with respect to 1 hydrogen atom in terms of atomic mass unit. Any doubt? Okay? Any doubts are there? If you have any doubts, let me know. Okay? So this is where. Please remember, no one will ask these things. Don't worry. Definition they will ask. This is for your understanding purpose. I have written it as 1 atomic mass. I have calculated for hydrogen. So when it comes to carbon 12, it will be 12 times more than that of the hydrogen. That means 12 atomic mass unit. If I take oxygen, it is 16 times more than that of the hydrogen. That means 16 atomic mass unit. Fine? So depending on the element, atomic mass unit is going to change. Okay? Now, another very important concept which we are going to discuss now here is that is related to mole and molar mass. Mole and molar mass. Molar mass, it can be represented as M. Molar mass, it can be represented as M. Unit will be in grams. Or we can go with the grams. We will not mention any unit. Otherwise, we will get confused with molarity. Okay? That one comes next. So that's why we have mole and molar mass. Okay? Now, when I am talking about the mole, first we have to define what you mean by mole. Because molar mass is related to the mole. Okay? Now, definition you can expect in your exam. Define a mole or what is a mole. Then you have to define it. Now I can tell that mole, it is a number. It's not a mass. It is a number. Okay? It's a number of elements or it's a number of substance which will be equals to. It is the number of elements or substance, anything, element or substances, okay, so which will be equals to, number of carbon 12 atoms, in 12 gram of carbon 12. In 12 gram of carbon 12. That's how we can define it. So what is mole? Please remember, it's not a mass. Don't get confused with atomic mass unit. In atomic mass unit it was mass. But here it is a number. That's where very important word. Number. It is a number of elements or number of substance which will be equals to the number of, once again we have the number of carbon 12 isotopes in 12 gram of carbon 12. That means if I take 12 gram of carbon 12 atom, okay, so now if I see the number of carbon in that 12 gram, so that number is nothing but 1 mole. All of you have understood? So that number is nothing but 1 mole. Whether I am clear? Any doubt in this? So that will be nothing but 1 mole. If you want to repeat me the explanation, I can repeat. So what I mean to tell here is, many times they have asked about definition for a mole. So what do you mean by mole? It is a number. This is important. It is a number of element or substances which will be equals to number of carbon 12 isotopes in 12 gram of carbon 12 atom. Fine. So that's where we have the mole concept. All of you have understood? So that means there is no gram. You should not tell gram unit. No unit, because it is just a number. Okay. So what is that number? Okay. So what will be that number? What is that 1 mole corresponds to? Fine. So in that case, I can tell that I have a information. Once again, please remember, no one will ask you to derive the mole number. No one will ask you from where that number came. To give that information, I am doing this one. Okay. So it's a simple one only. See, for example, 1 carbon atom, that is carbon 12 atom isotope, 1 carbon 12 isotope, it will weigh approximately 1.99 into 10 to the power of minus 23 gram. 12 times more than that of the hydrogen, that's all. 12 times more than that of the hydrogen. If you calculate, what is the mass of one hydrogen atom? 1.67, right? So if you multiply it by 12, you will get this one value only. So that's where we have 12 times more mass for the carbon 12 atom. So that is 1.99 into 10 to the power of minus 23 gram. Okay. So I am not talking about atomic mass unit. We are talking about mass. That is, I am mentioning gram. Okay. So that is the mass of 1 carbon atom. Okay. So in that case, these many gram if I take, it corresponds to 1 carbon atom. So these many grams corresponds to how many carbon atom? Okay, I will repeat it. See, for example, when I am talking about mole, it's a number of elements or substance which will be equals to the number of carbon 12 atoms in 12 gram of carbon 12 atom. Fine. So in that case, if I want to see what is that value, what is that number, to find out that one, what we are doing here is, we know the information that 1 carbon atom if I take, it's going to weigh somewhere around 1.99 into 10 to the power of minus 23 gram. It is exactly 12 times more than that of the hydrogen atom. If you recollect, 5 minutes back I have told, one hydrogen atom will weigh 1.67 into 10 to the power of minus 24 grams. So if you multiply it by 12, you are going to get this one. That's where 1.99 into 10 to the power of minus 23 gram. That is the mass of 1 carbon atom. I am not talking in terms of atomic mass unit. So that is the mass of 1 carbon atom. Now we can calculate how many atoms will be there in 12 gram. How to do that one? That will be done by, for 1.99 into 10 to the power of minus 23 grams of carbon, it corresponds to 1 carbon atom. All of you will agree? It corresponds to 1 carbon atom. Okay, Yagnesh, I will come to that. It's actually there in your atomic structure. Anyway, I will tell that one. Okay. So 1.99 into 10 to the power of minus 23 gram corresponds to how many carbon atom? 1. So how much will be there for 12 grams of carbon? For these many grams of carbon, it is one carbon atom. For these many grams of carbon, how many carbon atom? If you calculate it properly, okay? Anyway, 10 to the power of minus 23, when you take it up, it will become 10 to the power of 23. Minus 23 will become plus 23. So 12 divided by 1.99, somewhere around 6.022. Somewhere around 6.022. So this is the number with respect to the mole. Please remember, it is also called as Avogadro's number. It is also called as Avogadro's number. So what is that number corresponds to? This number is nothing but this is the value 6.022 into 10 to the power of 23. Okay, na? Stefan. Okay, 1.99 into 10 to the power of minus 23. So that is because one carbon mass it is. 1.99 into 10 to the power of minus 23 is mass of one carbon atom. If you calculate it is exactly 12 times more than that of the hydrogen, where hydrogen is 1.67 into 10 to the power of minus 24. So 1.67 multiplied by 12, it will be somewhere around 19.9. By making it as 1.9, I can have this value. Fine? Because it is 12 times more. Fine? That's where I have got this value. Anyway, don't worry. No one will ask to deduce this particular number, but you have to remember this number. This value you have to remember. How it will come, derive that one, no one will ask. Don't worry. Okay, that's why we have the Avogadro's number. Okay, so which can be represented as Na. N capital, A capital, but A should be written subscript. Okay, so that's where we have the Na, Avogadro's number. That is nothing but 1 mole. That corresponds to 1 mole. Okay, Yagnesh. Okay, very good question. I was expecting this. Why they took carbon? That also carbon 12. So before that, Yagnesh was having the question that what are isotopes? Iso means same. Topos means position. Isotopes are those group of elements which will occupy the same position in the periodic table. Isotopes are those group of elements which will occupy the same position in the periodic table. How it's possible, sir? That is because they will be having same atomic number. Say for example, if I take carbon, all of them, we have 3 isotopes of carbon, all of them having atomic number as 6. But atomic mass they are going to vary. 12, 13, 40. But my point, they are nothing but isotopes of carbon. Now if you observe it carefully, do you really think, I'll come to that, Rohan, I'll come to that. So do you really think whether we have 3 positions for the carbon in the periodic table? No. Everything will be represented in one place, where if you observe in the periodic table, carbon is placed next to we have boron, right? Group 13. Next to the boron, we have the carbon. Before to the nitrogen, we have the carbon. So that is the position of carbon, and only one position for the carbon in the periodic table, which includes all the 3 types of carbon. That's why they are called as isotopes. Same position in the periodic table. Or we can define it as these are the elements which are having same atomic number but differs in their mass number. Okay, Siddhant, you are not understanding which one? About isotopes you are not understanding? So don't worry about isotopes. In detail we are going to study in atomic structure, that is next chapter. But since there was a question on isotope, I am explaining. Siddhant, which one you are not understanding? Whether you are not understanding the mole or isotopes. You can mention mole or isotopes. Which one you are not understanding? Let me know. So that I can repeat it once again. But for others, I can tell that, no, if you are not understanding, you should raise the voice, no doubt. So when I am talking about isotopes, so these are the elements which differs in their mass number. No need to ask sorry and all. Why you are asking sorry? Which one you are not understanding? That's what I am asking. So when I am talking about isotopes, okay, so these are the elements which will be having same atomic number but differs in their atomic mass or mass number. Differs in their mass number. Please remember, in an element, subscript will be always representing the atomic number. Superscript always it will be representing the mass number. And periodic table elements are arranged based on their atomic number, not based on their mass number. Fine? So that's where, since they are having same atomic number, they have to occupy the same place in the periodic table. We don't have three different places for the carbon. One for carbon 12, another one for carbon 13, and another one for carbon 14. No. All of them will be in same position. So therefore this word has been coined. Iso stands for same. Topos means position. So therefore they are called as isotopes. Now we have understood, all of you have understood. Any doubt you can ask. If you are asking a doubt, no need to ask sorry and all. If you have a doubt, you can ask. Yes, with these are the elements which will be having same atomic number. But if you write only that much answer, you will not get the marks, because in atomic structure this one will come. So you have to extend further. You should tell that they have same atomic number but differs in their mass number. That word has to come. They differs in their mass number, and this is the example. So therefore, if you remember, carbon 12 isotope I was telling. So therefore, you people ask me, what do you mean by that isotope? That's why I gave this explanation. Okay? Now, next, why they selected carbon 12? A beautiful question. Why they have selected carbon 12? One reason is carbon 12 is a stable isotope. They are not radioactive in nature. If you recollect, carbon dating in SSS you might have studied. Carbon dating, it is by using carbon 14, which is a radioactive element, right? Anyway, it's having long lifespan. That is a different story. But carbon 14 is a radioactive element. So therefore, it will be used for carbon dating purpose. That is why we have carbon 14. Now, okay, fine, we will not go in detail. What I mean to tell you is, they have taken carbon 12 because they are abundantly present in the nature, right? So they are abundantly present in the nature. That is one point. And next point here is, they are stable. Carbon 12, they are stable. So therefore, they went with carbon 12 due to its stability, due to its abundance in the nature. So therefore, they went with carbon 12 isotope. Okay? So all of you have understood. Otherwise, in the beginning, earlier, this carbon 12 they accepted somewhere around 1956. But before that, they used to take oxygen. But later, they shifted to carbon 12. Fine? So that's where we have the mole, definition for the mole. And we have to remember this value. Okay? We have to remember this value. Now, mole concept not only for chemistry, everywhere you can apply. Mole and molar concept you can apply everywhere in our day-to-day life. See, for example, what is that 1 mole of Raghavendra, sir? Oh, sir, 1 Raghavendra sir is only torture. Why 1 mole? Right? So 1 mole of Raghavendra sir means I am 1. If I have Avogadro's number of Raghavendra sir standing here, which is not possible, okay, we cannot accommodate also. It's a huge number. So that many Raghavendra sirs is nothing but 1 mole of Raghavendra sir. 1 mole of this particular marker. That means I should take Avogadro's number of this marker. Then it will become 1 mole of this particular marker. Everywhere we can apply. Fine. So that is related to mole. If you have understood this one, now it will be easy to understand this one also, which is also very important. Molar mass. In the name itself it is there. Now I can tell that molar mass. So in the name itself it is there. It is a mass. Just like atomic mass unit. So it is a mass. It is a mass of 1 mole of a substance. It is a mass of 1 mole of a substance expressed in grams. Expressed in grams. So what do you mean by molar mass? It is the 1 mole. It is the mass of 1 mole of a substance which are expressed in grams. So that's where we have the molar mass. All of you have understood? So what do you mean by molar mass? It is the mass of 1 mole of substance. Done. It is the mass of 1 mole of substance. We can extend it as it is expressed in grams. Or you can simply write it as it is the mass of 1 mole of substance in grams. That is also fine. It is the mass of 1 mole of substance in grams. That is also fine. That is the definition for molar mass. That is the definition of molar mass. A simple logic, this one we will discuss. Say for example, if I take molar mass of carbon, if I take, yes, Stephen, I am going that one only. So molar mass of carbon if I will take it as 12 grams. Just now we have discussed it, right? For 1 mole, we took 12 gram of carbon. That is nothing but atomic mass. We will consider it as atomic mass since we have taken carbon as one atom. But we can express in terms of molar mass. It is nothing but 12 grams. That is nothing but 12 grams. If that means if I take 6.022 into 10 to the power of 23 number of carbon, it will just weigh 12 gram. It will just weigh 12 gram. That's where we should appreciate. Because as a biology student, some of you might have taken computer science, some of you might have taken biology. So as a biology students, we know all of us, we are having n number of carbon. We don't know how much it is. We have n number, infinity. We don't know how much it is. N number of carbon. By chance, if each carbon start weighing 12, then our mass would have been more than the mass of the solar system. I am not talking about Earth, solar system. Right? Say for example, my mass is now, Raghavendra sir's mass is now 65 kg. Right? Raghavendra sir's mass is now 65 kg. Thank God. That is because I have so many atoms in my body. All these atoms are of low mass, very, very low mass. Right? By chance, if each carbon start weighing 12 gram, then I have n number of carbon atom in my body. So total mass of my body will become more than this particular universe. Right? So simply any atoms in 1 gram, number of molecule is called mole. Okay, definition, some problem is there, Siddhant. So that should not be the definition. You are writing it as simply any atoms in 1 gram number of molecule is called mole. No, 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 no. Mole is nothing but a number. What is that number? Avogadro's number. So this is the number. That means 1 mole of any element. Right? So now it's a number. If I take 1 mole of any element, if I see that mass of those elements, that will give molar mass. In this case, I have taken 1 mole of carbon. I have taken 1 mole of carbon. This number corresponds to 1 mole of carbon. That will weigh just 12 grams. Same way, if I take 6.022 into 10 to the power of 23 number of hydrogen atom. That means I am taking 1 mole of hydrogen. It will just 12 times less than that of the hydrogen. That will be 1 gram. That will be 1 gram. Now, if I take 6.022 into 10 to the power of 23 number of oxygen atom, that is 1 mole of oxygen atom, it will weigh 16 gram. It will weigh 16 gram. All of you have understood? Got my point? That's where we have the difference. If I take hydrogen, if I write it as 1 AMU, that means I am talking about 1 hydrogen atom. If I take carbon as 12 AMU, I am just talking about 1 carbon atom. If I take oxygen as 16 AMU, I am dealing with 1 oxygen atom. But the same thing, if I express in terms of 12 gram, that means I am not dealing with 1 carbon atom. I am dealing with a group of carbon. That means Avogadro's number of carbon atom. Same logic is applicable. If I am writing hydrogen as 1 AMU, I am talking about 1 hydrogen atom. But if I am writing it as 1 gram, that means I am dealing with group of hydrogen atom. So how many atoms are there? 1 mole of hydrogen. That is Avogadro's number. Right? Same logic is applicable everywhere. If I take 1 Raghavendra sir, it is 65 kg. Right? But if I go with Avogadro's number of Raghavendra sir, we cannot imagine the value. Right? So that's where we have the molar concept. It's a huge number. Avogadro's number is a huge number. Since I have written in scientific notation, you people are thinking that okay, Avogadro's number is there. If you go with regular presentation of this number, then you will see so many number will give just 12 gram for carbon. So many number of oxygen atom will give just 16 gram, right? Say for example 6.022, right? 6022, right? 10 to the power of 23 will become, I have 6.022 into 10 to the power of 23. So if I want to make it as 6022, that means decimal point I am shifting. Decimal point I am shifting. I will write it as into 10 to the power of 23, or how much it will be? It will become 20. It will become 20. Yes, very good. Someone had written, I think. Yes, 20. So therefore, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Right? Such a huge number of atoms if I take, it will give its molar mass. It will give its molar mass. So that means so many number of hydrogen, poor fellow, So many number of hydrogen, just 1 gram. Even I have removed decimal point upon. Okay, therefore it will become 20. So right. So if I take so many number of oxygen, just 16 gram. But if I take so many number of Raghavendra sir, we cannot calculate. Fine. So that's where we have the mole concept. That's why we should appreciate this mole concept. Very, very important one. That is the difference between atomic mass unit and mole concept, molar mass. Atomic mass unit and molar mass, that's where we have the difference. When it comes to atomic mass unit or Dalton's unit, it will be one element we are discussing. But when we are talking about molar mass, we are talking about mole of that particular substance. Fine, all of you have understood? Shall we move to the next one? Okay. Now, next one is, we have average atomic mass. Another concept here is average atomic mass. Now, when I am talking about atomic mass, that means we are discussing about the mass of that atom. What is that mass of that atom is nothing but atomic mass. Right? Now we are talking about average atomic mass. What do you mean by average? Average means we will be having two values and we will add these two values and we will divide it by 2. So that we can take the, or we can get the average value. That's how we used to do, right? So when I am telling average atomic mass, that means I am dealing with more than one value. I am dealing with Yagnesh. Yes, I am dealing with the more than one value. Then only I can go with average atomic mass. Right? So if you observe periodic table, if you observe the periodic table, you can go through periodic table. Most of the element in that periodic table, if you observe their atomic mass, it will not be a round figure. It will be in decimal points. Say for example, if I take carbon, they will mention it as 12.011. Like that it will be mentioned. 12.011. How come an atom can weigh 12.011? Means when I am talking atom in the sense, I am dealing with number of neutron, number of protons. So they cannot be in fractions, right? When we are weighing our mass, that is fine. It will be in fractions and all. 60.5 some kgs. That is fine. But here we are talking about number of proton and number of neutron. So they cannot be in fractions. But still, we are going to have the mass in fractions. What is that reason? That is because whatever value is given, that is not the simple atomic mass of carbon. It is the average atomic mass of carbon. It is the average atomic mass of carbon. Say for example, if I see the nature, I have carbon 12. Okay. For everyone, board is not visible. Okay, fine, 1 minute. Now can you see? Now can you see? Andani, right? Now can you see? Prithvi, now board is visible. Okay, Prithvi. What about Andani? Whether board is visible now? Because for others it is visible, it seems. Okay. So if that is the case, you may have to restart. Okay, fine. So now that's where we have the average atomic mass. For example, I was taking for carbon 12, which is there in your textbook also. if I take carbon 12 or carbon as the example, where we have total how many isotopes? Just I told we have 3 isotopes for carbon. Okay, and highly abundant one is carbon 12, which is somewhere around 98.8%. If I take 100 gram of carbon from the nature, imagine you are going to a shop to purchase the rice, and what they will do, they will take the rice and they will start weighing. Same way, from the nature, if I take the carbon like this, if I hold it in my hand, that carbon will be having a mixture of all these 3 isotopes. It will be a mixture of all these 3 isotopes. Fine. So that's where if I take 100 gram of those carbon in the nature, so in that 98.8% of will be carbon 12 type. Got my point? It will be carbon 12 type, abundant one. So after that comes the carbon 13, which will be somewhere around 1.1%. I am writing approximate value. It will be somewhere around 1.1%. If I take carbon 40, very less, it will be somewhere around 2 into 10 to the power of minus 10. 2 into 10 to the power of minus 10, very low value. That will be the abundance in the nature. That is the abundance in the nature. Anju, I will define. First we will go with explanation. I will define it once again, don't worry. So when I am talking about average atomic mass, it is not a simple atomic mass where we are taking one atom and we are expressing its mass. Right? But when I am talking about average atomic mass, we have to consider all the isotopes of that particular element. We have to consider all the isotopes of that particular element. Yes, Prithvi, I will explain it. Okay? So that's where we have carbon 12, carbon 13, carbon 14. Because we know that average atomic mass of carbon is 12.011. From where those value came? That is the question. From where those value came? So to answer that, I have written this one, their abundance in the nature. Their abundance in the nature. Whose? These isotopes of carbon. How much they are present in the nature. Abundance means, what is that percentage occurrence in the nature? So based on that I have written. Okay. Now we know that atomic mass of carbon 12 is 12 gram. Atomic, if I am talking about mole, otherwise atomic mass unit. So atomic mass unit, if I want to tell, atomic mass unit of carbon is 12U, and this one will be 13U, and this one will be 14U. Fine. So that's where I have the atomic mass unit for the different isotopes. So that's where I have the atomic mass unit for the different isotopes. Fine. And this is their percent occurrence. This is percent occurrence. This is atomic mass unit for these isotopes. Now I have to pull all these values. So what I will do is, say for example, if I take 12 gram or 12U, if I take 12 gram of this one, if I take 12 gram, now I can tell that for 100 it is 98.8. How much will be there in 12? For 100 it is 98.8 because it is percent occurrence, right? For 100 gram it is 98.8. How much will be there in 12 gram if I consider? How much it will be there in 12 gram? So that's where I will get it as 98.8 divided by 100 is nothing but 0.988. 0.988 into 12. That is one value. All of you will agree? That is one value after solving this one. Okay, I have got this value. Now I will come to the second one. What is that percent occurrence? 1.1%. Right? It is somewhere around 1.1%. That means if I take 100 gram, I will get 1.1 gram as this one. How much will be there in 13 gram? If I consider it in grams, how much will be there in the 13 gram? Okay? How much will be there in the 13 gram? I will repeat, don't worry. So 1.1 divided by 100 is nothing but 0.01 multiplied by 30. So this one we have got it from here. Same way, I will explain it once again. First I will write it down. Same way, here also I will come. If I take 100, it is somewhere around 2 into 10 to the power of minus 10. Okay? So how much if I take 40? How much if I take 40? Right? So that means it will give the value as 2 into 10 to the power of 2 it is. If I take it up, it will become minus 2. That means 2 into 10 to the power of minus 2. 12 multiplied by 40. All of you have understood? Now I will tell. Okay? So when I am talking about average atomic mass, we have to consider average atomic mass. It is average of all the isotopes and their occurrence in the nature, percent occurrence in the nature. Now, based on this study, we know that among the carbon atom, we have 3 isotopes: carbon 12, carbon 13, carbon 14. Okay? So we have 3 isotopes for the carbon. Now, in that carbon 12, it is occurrence in the nature is 98.8 percentage. So what do you mean by percentage? Percentage is related to something related to 100. So that means if I take 100 gram of carbon from the nature, in that 98.8 gram will be carbon 12 only. That is the percent occurrence of carbon 12 in the nature. Same way, if I take carbon 13, that means if I take 100 gram of carbon from the nature, in that approximately 1.1 gram will be carbon 13 only. Okay? Now, if I take from the nature 100 gram of carbon, in that carbon 14 will be just this value, 2 into 10 to the power of minus 10 gram. Very less value will be there for carbon 14. Now, we know that if I take atomic mass for carbon 12, it will be 12 gram. If I express it in atomic mass or atomic mass unit, it will be 12 U. Carbon 13, it will be 13 gram. Carbon 14, it will be 14 gram. Fine, as an individual atom. Okay. So while calculating average atomic mass, what we will do is, we will also consider their percent occurrence. So due to that, what we will do is, if I take 100 gram of carbon from the nature, in that 98.8 will be carbon 12. But if I take 12 gram from the nature, how much will be carbon 12? That's what you are going to get from this one. Now if I come to second one, if I take 100 gram from the nature, that is carbon, it will have 1.1 gram as carbon 13. But if I take 13 gram from the nature, how much it will be? Then we are going to further solve this one. Same way this one if I take 100 gram from the nature, it will be 2 into 10 to the power of minus 10 gram of carbon 14. But how much will be there in 14 gram? So why we are considering 12, 13 and 14? Because we are calculating individually. Right? So since in the nature all of them they are present together, so we have to add them on. We have to add them on. So to calculate this, don't worry, no one will ask you to calculate the average atomic mass. So we have to add them on. That means 0.988 multiplied by 12 plus 0.01 multiplied by 13 plus 2 into 10 to the power of minus 12 multiplied by 14. It may not be exactly 12.011 because I have not taken exact values. Especially this one, I have not taken exact values, but it will come somewhere around 12.011. That's where we are going to have the average atomic mass of a element. All of you have understood? So in that case, now I can define what do you mean by average atomic mass. No one has asked, but for your information, average atomic mass means it is the mass of the element considering their abundance in the nature with respect to their isotopes. Okay? So what do you mean by average atomic mass? It is the average mass of the isotopes and their occurrence in the nature. Okay? So average atomic mass is nothing but it is the total of mass of isotopes and their occurrence in the nature. That will give the average atomic mass. But if I take simply as atomic mass, then there is no percent occurrence. Only simply as atomic mass means yes, 12 gram, 13 gram, 14 gram, done. Because this one has a single atom or this one has a pure carbon 12 I am talking about. But when I am talking about average atomic mass, I am dealing with isotopes, group of carbon. Got my point? Therefore, in the periodic table, always you can see element will be having average atomic mass because in the nature, carbon 12 is not present separately, carbon 13 they are not present separately, and carbon 14 they are not present separately. All of them they are present together. So therefore, average atomic mass has been mentioned in your periodic table. But when we are calculating, when we are using it for calculation purpose, we will consider this one as 12. Got my point? We will consider that one as 12. Otherwise, it will be difficult for calculation. 12.011 if I take. So I will round it off. I will take it as 12. Now all of you have understood? Any doubts? Anyway, I will stop here, don't worry. So tomorrow what we will do is, we will solve some of the example where we will calculate the molar mass of some compounds, some molecules. Okay? So any doubt? So in that mole, atomic mass unit, molar mass and significant figures. These are all important ones. Sorry, appa. These are all important ones. Okay? So any doubt in this? Okay? Now, don't worry about how Avogadro's number came. No need to remember those values. But you have to remember only with respect to Avogadro's number. That value you should remember. Yagnesh, once again same mistake. Fine. Okay na? So then, that is with respect to Avogadro's number. That one you should remember. How it came, calculation, don't worry. Same way, average atomic mass. You should know what you mean by average atomic mass. So no one will ask you to calculate the average atomic mass for carbon. Okay, don't worry. But you should know how it has been calculated. Fine? All of you have understood? Fine. In that case, I will stop here. If you have any doubt, don't worry. Tomorrow also you can ask. Okay? And tomorrow we are going to solve some of the problems related to finding the molar mass of a given compound. That can be asked. Okay? Okay. Thank you. Thank you very much. Take care.